Hello, what's up everyone? Welcome to this live stream where we're going to explore and discover one of the most new exciting features that were added to Swift this WWDC. We're going to talk about Swift macros. Yesterday, we already explored Swift Data, Apple's new persistence framework for Swift apps. And this time, we have an even better advantage that we didn't have yesterday, which is that I have found a very good walkthrough of how Swift macros work on Apple's website, on the documentation. And so this time we are not going into the wild as much as we have been yesterday. We have something to guide us, and this should make this live stream a little bit more, I don't know, structured than what we did yesterday. I'm just realizing I forgot to display the chat. Oh yes, so I see people, I see Arj, I see Asmi, I see Frank. Welcome back. I hope you will enjoy this new live stream. Before I start, I just want to say the usual disclaimer for the people that might be watching the replay months or even years in the future. I am doing this live stream 2 days after the keynote of WWDC 2023. So whatever I'm showing you is still in beta, even though this time we're talking about a feature of Swift, of the language itself, and usually these ones seems to be more stable than the framework APIs, mostly because they have already been debated in public, but still there could be some differences between what I'm showing in the live and what will actually happen when the API, when the feature is released for everyone. Even though officially Swift 5.9 has already been released, so what we are looking at should be the definitive version of macros, at least for this version of Swift. So let's get started. If you want to follow along on Safari, you have the link to this web page in the description, by the way. So macros in Swift, they are a feature that allows you to transform your source code when you compile it, letting you avoid writing repetitive code by hand. So we can see kind of a similarity with property wrappers, and we will see that at the code site, macros can be used in a similar fashion than property wrappers, kind of like annotations. And during compilation, Swift expands any macros in your code before building your code as usual. So this is very important to understand, because it means that basically a macro, you can see it as kind of like, honestly, it's basically a small compiler in a way, because it takes in source code and it generates new source code. So you can really see it as a small compiler. It's a code generation tool. So if you've ever used Sourcery, this should feel quite similar, at least in the big picture principle, because the syntax to interact with macros might be different than what we are using with Sourcery. So here we have this nice little illustration that I use for the thumbnail. You have the source code, and once the macro has been applied, you have expanded source code, so with new code being added. And this is important, this word added, because the next line says that expanding a macro is always an additive operation. Macros add new code, but they never delete or modify existing code. Both the input to a macro and the output of a macro expansion are checked to ensure the syntactically valid Swift code. So it's not like the code is being shipped and whatever happens. It's still being compiled and checked by the compiler. Likewise, the values you pass to a macro and the values in code generated by a macro are checked to ensure they have the correct types. So it's kind of different in that respect to macros in C. If you've ever used macros in C, they are not checked. They are not type checked, in the sense that you will call your macro, it will generate some code, but if there is an error in the type you're passing, you will only see it when the generated code builds. Whereas here, I think the arguments you could pass to a macro, they are typed, and Swift can verify that you are indeed calling a macro with the correct type. Like if the macro is expecting a string and you're passing it an int, it will result in a compilation error, if I understand it correctly. In addition, if the macro's implementation encounters an error when expanding that macro, the compiler treats this as a compilation error because macros are Swift programs. They can fail, they can crash, they can have all the kind of issues that a program can have. I wonder if they can loop forever, but it could very well be possible. These guarantees make it easier to reason about code that uses macros, and they make it easier to identify issues like using a macro incorrectly or a macro implementation that has a bug. And if you've ever used code generation, like if you've been an enthusiastic user of code generation, you might have been in the situation where you had some generated code that just didn't behave like you wanted it to behave, but you had so much trouble finding what was going wrong, kind of like we had yesterday with Swift Data that uses some macros to work. And having this support is going to be a nice help, even though, as we saw yesterday, we can still get some very puzzling error messages. So Swift has two kinds of macros: freestanding macros that appear on their own without being attached to a declaration. So if I understand it correctly, these are the ones that we invoke using the hashtag symbol, and attached macros that modify the declaration that they're attached to. So the ones that act kind of like annotations. And for these ones, what I understand is that we use the at symbol that we were already using for things like property wrappers, like actors annotations. You call attached and freestanding macros slightly differently, but they both follow the same model for macro expansion, and you implement them both using the same approach. The following sections describe both kinds of macros in more details. So let's see. First, freestanding macros. To call a freestanding macro, you write a number sign. Okay, so what I was calling hashtag is actually called a number sign before its name, and you write any arguments to the macro in parentheses after its name. So for example, we have pound or hashtag function and hashtag warning, and these two macros, I think they are already macros that already exist, except that they are implemented in the compiler, or at least in the language, in the Swift language, and you couldn't create them by yourself. It will be interesting to see whether they have been re-implemented using the new syntax or not. So in the first line, so here, hashtag function calls the function macro from the Swift standard library. When you compile this code, Swift calls the macros implementation, which replaces hashtag function with the name of the current function. When you run this code and call my function, it prints currently running my function and then parentheses. In the second line, hashtag warning calls the warning macro from the Swift standard library to produce a custom compile time warning. Freestanding macros can produce a value like hashtag function does, or they can perform an action at compile time like hashtag warning does. So in a way, the macros we are already using in Swift up until today were freestanding macros, even though I think we're gonna see like different ways to use these freestanding macros, because the new hashtag preview syntax is a freestanding macro and we can use it to define a type. So it's a little bit more powerful than just things that look like function calls. So we will see a bit more later, I guess. And then we have attached macros. So to call an attached macro, you write an @ sign. So this one, I knew how to pronounce it. I knew its name correctly before its name. And you write any arguments to the macro in parentheses after its name. Attached macros modify the declaration that they're attached to. They add code to that declaration, like defining a new method or adding conformance to a protocol. For example, consider the following code that doesn't use macros, so a declaration of an option set, which was a syntax with quite a bit of boilerplate code indeed, because option set, if you've never used it, it's basically a way to define a type where you can do you can do combinations, and it does this by using the logical OR to do the combinations. So it uses like bitwise operation, and so the idea is that you have several possible toppings, and you can see that it's one being shifted by either 0, 1, or 2 bits, and then you can combine the two of them using you can combine 2 or more of these using a logical OR. And what option set does is that it wraps these logical operations into set operation in order to have more of an algebraic, more algebraic operators like union, difference, that kind of thing, instead of just using bitwise operations. but there was this boilerplate code, and so I guess we're going to see a macro that allows us to implement this. So in this code, each of the options in the Sunday toppings option set includes a call to the initializer, which is repetitive and manual. It would be easy to make a mistake when adding a new option, like typing the wrong number at the end of the line, especially if you duplicate an existing line to add a new one. Here's the version of this code that uses a macro instead. So we have the option set macro, and we can give it a type, which is int, because I guess maybe we can do the same thing with like unsigned ints, maybe that's why. So we will try it just after, but I want to keep reading for now. So this version of Sunday toppings calls the option set macro from the Swift standard library. The macro reads the list of cases in the private enumeration, generates the list of constants for each option, and adds a conformance to the option set protocol. Okay. What's interesting is that we still need to provide the int type here, even though it's still accessible here. So it's interesting that the compiler isn't able to infer this thing. And what happens if the two don't match? Do I get an error? That would be pretty interesting. You're saying you missed the live last night. It's available on my channel. You can check it out just after, but the replay is already available on my YouTube channel. So let me see, where was I? Okay, I was here. So conformance, all right. For comparison, here's what the expanded version of the option set macro looks like. You don't write this code, and you would see it only if you specifically asked Swift to show the macros expansion. So this is what you write and what you commit in your source code, and this is what is, we could say, expanded, what is generated by, it's kind of a compiler preprocessor in a way. So it adds all of this code, so it's similar to what we have in the handwritten version, except that it's more low level and more like boilerplatey. But since it's generated automatically, it's not a problem at all. And all of the code after the private enumeration comes from the option set macro. The version of Sunday toppings that uses a macro to generate all of the static variables is easier to read and easier to maintain than the manually coded version. So this is easier to read and maintain than this. So, okay, let's actually try it. So what I did is that I downloaded Xcode 15. I created a new project, so I made it a macOS project and made it a command line tool. This way we can have a playground-like ergonomics where we just have the main file and we can write top-level code here. So I implement the struct with the private enum inside of it. And now let's see. So option set, does this build or not? I get an error because the parameter row type could not be inferred, so I need to provide it. Okay. This time build succeeded. All right, that's pretty cool. Trying to see if there is a command to expand the macro. All right, so that's pretty nice. That's pretty nice. We can indeed see all of the code that we were seeing in the documentation. So we can see the code being generated and then the conformance happening in an extension. I'm wondering if the fact that the conformance happens in an extension is more of a coding style choice, or if it's because you cannot add a conformance to an existing type. Because remember, it said that modification can only be additive, and I guess I'm wondering whether adding a conformance here would be considered an addition or a mutation of the existing struct declaration. Maybe we'll get to understand this a little bit later. Okay. And what happens if here I put something different, like if I get rid of int, for instance? Interestingly, if I get rid of int, you can see that the errors are reported here, but they don't appear here. Do they appear if I expand the macro? No, they don't. So hopefully this will improve, because here you still get the error, but you see it's not that easy to understand. Right? So let me see. I'm going to put it back, and I wanted to check what if I do something else here, like if I put u in, for instance. Okay, so it also works. So I guess the two here actually are unrelated, and I thought that they were related, but it was a mistake, because if I expand the macro, we can see that, okay, so the struct has a raw value which is a uint. So here it's option. Oh, okay, so it's like this option set uses a uint as its raw value, and then it uses the raw values of the internal enum, which is a different raw value, to shift the one bitwise. Okay, okay. So yeah, so it's this thing, and this thing, and I'm trying to see, and the raw value here is going to correspond to yeah, it doesn't have to be related, indeed, but I guess this should still be like a numerical type. Like if I put a string here, I guess, yeah. So I guess maybe when I do like a uint, I could get like more possibilities, because I have a little bit more ints that are like I mean non-negative ints that are allowed. Actually, I struggle a bit to understand why it doesn't default to a specific type right here. But I haven't used option sets that much, so that might be why, because the raw value. So we have the enum, and then so the enum are the individual possibilities, and then the raw value is the mix of these possibilities here. So I would like to actually, what I want to see is the implementation, because the raw type, does it have any kind of constraints? Oh, okay, it's because you might want to have shorter. Okay, that makes more sense. For instance, if you have only 4 cases, then it doesn't make sense to take maybe like a 32 or a 64-bit integer, and just having an 8-bit integer is more than enough. Actually, here, even like 4 bits would make sense, but since it needs to be a multiple of 8, I guess, uint 8, okay, so it's because it allows you to specify lower values, and I guess if you're doing code that is more low level, it does make sense to use lower ints. And you were saying it can be more than 63. Interesting. So I can understand it. So 633 at 64 minus 1. So even if you do like uint, the extra bit that you get because you're no longer caring about the sign, you don't get like one extra value. Okay, you have uint 6, which is smaller. That's interesting. I must say I haven't written that much of low-level code. Actually, you know what? I'm not even sure that I've ever used an option set in production code. I remember reading about it when it was released in Swift, but I am not sure I have ever used it in production code. But I guess it's more necessary when you implement low-level things. For instance, if you do I'm thinking typically people that do communication with connected objects using Bluetooth Low Energy, where you're sending like data frames across the network. I guess it makes much more sense to use an option set in this context. Okay, let's try to go back to the documentation. So macro declaration, how do we create our own macro? In most Swift code, when you implement a symbol like a function or a type, there's no separate declaration. However, for macros, the declaration and implementation are separate. Interesting. It kind of brings us back to the days of Objective-C, when we had the .h and the .m separated files. A macros declaration contains its name, the parameters it takes, where it can be used, and what kind of code it generates. A macros implementation contains the code that expands the macro by generating Swift code. You introduce a macro declaration with the macro keyword. So here, for example, here's part of the declaration for the @OptionSet macro used in the previous example. So this is the declaration and not the implementation. So you know what? Let me go back in Xcode to see. This is what we were seeing just before. And so public macro, so the name OptionSet, the generic argument. What's interesting is that there might be constraints on this generic argument, but they don't seem to appear on the declaration itself. And then we have this hashtag external macro, but I guess they explain what it is just after. So the first line specifies the macro's name and its arguments. So name here, argument in the form of a generic type, and then no arguments, but we could have added arguments. The name is OptionSet, and it doesn't take any arguments. And the second line uses the external macro module type macro, so it's a bit meta, from the Swift standard library to tell Swift where the macros implementation is located. In this case, the Swift macros module contains a type named OptionSet macro. So I guess this is like some kind of struct or class or whatever that implements some kind of protocol. And so you say, okay, this is in this module and in this type. It's interesting that Swift isn't able to make that link by itself. And I'm also curious to see, like, do the two things like the declaration and the implementation, do they live inside the same Swift package, or do you have to declare the macro like inside your app? It's still a bit mysterious, but hopefully we should get some answers soon. And so in this case, the Swift macros module contains a type named OptionSet macro, which implements the @OptionSet macro. Okay. And you were saying, can you create a macro for that? So can you create a macro to automatically generate this declaration for you? That might be possible. Maybe that's even what Swift does, because we already have a macro right here. It seems like once you've introduced macro to a language, like you've opened Pandora's box and everything could be implemented by a macro under the hood. So because OptionSet is an attached macro, its name uses upper camel case, like the names for structures and classes. Freestanding macros have lower camel case names, like the names for variables and functions. That makes sense. Note, macros are always declared as public, because the code that declares the macro is in a different module from code that uses that macro. There isn't anywhere you could apply a non-public macro. So I guess this means that you declare the macro inside. That's interesting. So the code that declares the macro is in a different module from the code that uses that macro. And it seems like it's not like a should, it's more like it must be. So I think this is a way to enforce a strong independence between the code, to make sure that your macro code is not manipulating some kind of global variable that it shouldn't be. It's a way to kind of isolate, kind of sandbox the macro. And so if a macro must be in a module of its own, indeed, if the macro wasn't declared as public, then you couldn't use it nowhere, because I guess that in module that defines the macro, you can only define macro code and nothing else. Okay, a macro declaration defines the macro's roles, the places in source code where that macro can be called, and the kinds of code the macro can generate. Every macro has one or more roles, which you write as part of the attributes at the beginning of the macro declaration. Here's a bit more of the declaration for @OptionSet, including the attributes for its roles. So we have @attached member and @attached conformance. Okay, so you're saying, Frank, that the macro implementation is a plugin to the compiler. Yeah, that makes total sense. Let me put it in the live stream so that people can see it in the replay. So the code that implements the macro is indeed a compiler plugin, and it's kind of like what I guess I was saying that in the beginning, that we are with a macro we are implementing a small compiler or a compiler preprocessor, and so it makes sense for it to run sandboxed. Yeah, the need for a sandbox, it makes sense, because otherwise I guess it would be a security threat because people could use like put some kind of malicious code in the macro. I mean, there is already a security threat being there, but without the sandboxing, then I guess if the macro runs inside the compiler, it could do a lot of malicious things. So Andy, you're saying that macros are pure functions with no side effects. And indeed, I think we're going to see it a bit later, but when you think about it big picture, a macro, you can see it as a function indeed that takes in some source code and returns other source code by adding things to it. And in a way, once again, at a very high level picture, you can kind of see a macro as a modifier that you add on your code. You know, it's we see this similarity with modifiers that you call on a SwiftUI view, and the modifier returns a new view with some added behavior or configuration. We can kind of make the same analogy for the way that that macros work, even though the syntax is very different. It's interesting to see that there is this similar pattern. And so let's try and make more sense of this declaration. So the attached attribute appears twice in this declaration, one for each macro role. The first use @attached member indicates the macro adds new members to the type you apply it to. So the @OptionSet macro adds an initializer that's required by the OptionSet protocol, as well as some additional members. And I think these additional members are these ones right here. So they are static members. They are static members, but they're still members of the struct that the macro was attached to anyway. So this is what member allows, I guess. Okay, the second use @attached conformance tells you that @OptionSet adds one or more protocol conformances. The OptionSet macro extends the type that you apply to the macro to add conformance to the OptionSet protocol. We saw this through the extension that it generated. So it's interesting to see that the macro has to explicitly say what it will modify. It's kind of similar to the entitlements in a way that we have for iOS apps, where the app has to say like I will access the camera roll, I will send push notifications. There is this idea that the macro need to let the user know what it will do, and I guess it's also a way to kind of like maybe there are some roles that should like make you suspicious if you see some third-party code that use this. And indeed, macros are composable. You make a very good point, Humberto. Okay, and for freestanding macros, you write the @freestanding to attribute to specify its role. So here it's the macro line, so #line, which returns the current line, in your Swift code. And so we have expression. I guess there is also function, because I don't know, I'm curious to see like the other possibilities. So the #line macro above has the expression role. An expression macro produces a value or performs a compile time action, like generating a warning. Okay, so even the warning we saw before was also an expression. In addition to the macro's role, a macro's declaration provides information about the names of the symbols that the macro generates. When a macro declaration provides a list of names, it's guaranteed to produce only declarations that use those names, which helps you understand and debug the generated code. Here's the full declaration of @OptionSet. So let me read it again because it was a lot to take in. So a macro's declaration provides information about the names of the symbols that the macro generates. When a macro declaration provides a list of names, it's guaranteed to produce only declarations that use those names. Okay, so it's the names here. So it's going to generate a name called row value, another name called row value. Okay, so what they call names, I guess it's maybe what we call identifiers often. So okay, it's going to be init. Okay, what's interesting is that we have arbitrary at the end. So does it mean that it's going to generate this plus anything else that it wants? Okay. It also means that I mean, in a way, it might be a good thing, because it means that if you try to do a macro that does too many things, your declaration will become like crazy long. But yeah, I guess the names here could happen a lot. Could include a lot of things. I mean, but I'm curious to see what this arbitrary means. So in the declaration above, the attach member macro includes arguments after the name label for each of the symbols that the option set macro generates. The macro adds declarations for symbols named raw value, and init. Because those names are known ahead of time, the macro declaration lists them explicitly. The macro declaration also includes arbitrary, so we'll know what it's for, after the list of names, allowing the macro to generate declarations whose names aren't known until you use the macro. For example, when the @OptionSet macro is applied to the Sunday toppings above, it generates type properties that correspond to the enumeration cases, nut, cherry, and fudges. Okay, so if I go back to Xcode, and I go back to the expanded macro, so indeed, these things are static in the sense that they are known when you compile the macro. So the macro can kind of like proactively declare them. So this symbol here, and this symbol there. However, these ones, they depend of the content of the code that you are applying the macro to, and so it's impossible to predict them in advance. But this kind of begs the question of why is it necessary to declare explicitly the ones that we know? Like, what is the added benefit of doing so? Because since arbitrary is also allowed, I guess that giving also named names adds a benefit, the fact that we declare them ahead of time, and I'm curious to know what it is. And yeah, you had already guessed, asked me the reason for which we had this arbitrary. For more information, including a full list of macro roles, see attached and freestanding in attributes. You know what? We're going to go and check them to see what there is. We won't read everything because there might be, yeah, there are still a lot of them. So let's try and go over it, but maybe not go over everything. But we have peer macros. So write peer as the first argument. The type that implements the macro conforms to the peer macro protocol. These macro produce new declarations in the same scope as the declaration the macro is attached to. For example, applying a peer macro to a method of a structure can define additional methods and properties on that structures. That's interesting. Oh, I see what you mean. So I guess when you say that it's named, maybe the compiler can enforce the fact that they will indeed be there, in the sense that if a name symbol isn't present in the expanded code, then it's considered a compilation error, and it's kind of a way to test that. For instance, you know, if the macro like bugs and just generates some like just does nothing, it's a way to detect these errors. That might be the reason why. And the peer macros here, I find them very interesting because I had tried, like back when property wrappers were implemented, to introduce syntax similar to a networking framework on Android that's called Retrofit, and that uses annotations to say, okay, on this method, I want to have this argument, which is a get in my request. And I guess with these peer macros, you could implement something similar to the Retrofit syntax. So what macros get me really excited about is all of the possibilities it opens up for frameworks, whether they are Apple provided frameworks or third-party frameworks from the community. I think it will open up the way to a lot of exciting things. So we have peer macros, we have member macros. So these ones, they produce new declarations that are members of the type that the macro is attached to. So for example, applying a member macro to a structure declaration can define additional methods and property on that structure. So kind of similar, but you would call the member macro on the type and the peer macro on a member of that type. Member attributes. So these macros, they add attributes to members of the type or extension that the macro is attached to. So for instance, by adding attributes, I guess things like at auto closure, things like that maybe. And Umberto, you're saying, I really like the add async peer macro. Thank you for mentioning it. It's indeed a great example of a peer macro, and one that was, I don't know if it was this one or add completion handler that was demoed in the State of the Union, but one of these two was demoed during this event. Then we have accessor macros. So it's for controlling the access level, I guess. So things like, oh, maybe it's more for getter and setters, maybe. Conformance macros, we saw it's for conforming to a protocol, okay? And then the name, so name, where name is that fixed symbol name for a name that's known in advance. Overloaded for a name that's the same as an existing symbol, okay? Prefixed, suffixed, arbitrary. And a special case, you can write prefix dollar for a macro that behaves similar to a property wrapper. Okay, so I guess because you will create a symbol. Oh, it's because this way you will be able to use a dollar sign in front of whatever you've added the macro to. So I feel like it opens up the way for as many good practices I mean, it opens the way for as many good practices as many bad practices. You see what I mean? Like this can go like either way, but it's very interesting. And then we have some availability. Is it what was? Yes. So it's what was in the. No, all the links pointed to the same thing, but availability, it's to restrict the availability to either a platform or even a language. But when you say Swift, I mean, I guess macros don't work in Objective-C, so I'm not sure what this one means. And you can add, yeah, introduce, deprecated. Okay, all of these cool things. I'm going to go back. And yeah, like you were saying, Frank, if you already know the names, then you can generate new names based on them using prefix and suffix with some good level of compiler safety. And with our example, we had to put arbitrary because indeed it was arbitrary. But if everything had started with the same prefix, then we could have used it. Okay, so let's see. Yeah, we left there. Okay, macro expansion. Now we get to understand what's happening in the middle. When building Swift code that uses macros, the compiler calls the macros implementation to expand them. So specifically, Swift expands macros in the following way. So first, the compiler reads the code, creating an in-memory representation of the syntax. So what we see here, and from what I understand, I'm going to spoil a bit, but macros, they manipulate what is called, I think, the AST, so abstract syntax tree. So I guess this is what we are seeing right here. So the compiler reads the code, create this in-memory representation of the syntax, meaning, I mean, in the sense that the code, when you write it, it's a string, and then it gets parsed into a more structured syntax. Then the compiler sends a part of this in-memory representation to the macro implementation, which expands the macro. The compiler replaces the macro call with its expanded form. So for instance, if you're calling the macro on a type, I guess what is the macro call is the entire code with the type implementation. The compiler continues with compilation using the expanded source code in the sense that you could have a macro, like you could have a macro applied on a type and then another macro applied on a member of that type. So it's really, it's a cumulative process. Okay, so to go through the specific steps, consider the following. So we have constant being declared, and we use a macro called 4-character code, and we give it a string argument ABCD. So the 4-character code macro takes a string that's 4 characters long and returns an unsigned 32-bit integer that corresponds to the ASCII values in the string joined together. Some file formats use integers like this to identify data because they're compact but still readable in a debugger. The implementing a macro section below shows how to implement this macro. So are we going to see it? Yes, we're going to see this. I had a feeling that this was going to be a great document, and up until now, I haven't been disappointed, especially compared to like exploring Swift data with almost no documentation yesterday. So to expand the macros in the code above, the compiler reads the Swift file and creates an in-memory representation of that code known as abstract syntax tree or AST. So I read that on Twitter today, I think from Peter Fries, and yeah, that was indeed the correct thing, so I understood it correctly. The AST makes the code structure explicit, which makes it easier to write code that interacts with that structure, like a compiler or a macro implementation. Here's a representation of the AST code, of the AST for the code above. So this code right here, let me also show it. Slightly simplified by omitting some extra detail. So we have a constant declaration, then constant name, so magic number, constant value, so what is after the equal sign, a macro call, macro name 4 characters code, and macro argument. So we can see it's a tree structure as the name suggests, and it's basically like, yeah, it breaks down our code into a tree structure that is much easier to manipulate with code. So the diagram above shows how the structure of this code is represented in memory. Each element in the AST corresponds to a part of the source code. The constant declaration AST element has two child elements under it, which represent the two parts of a constant declaration, its name and its value. The macro call element has child elements that represent the macro's name and the list of arguments being passed to the macro. As part of constructing this AST, the compiler checks that the source code is valid Swift. For example, hashtag 4 character code takes a single argument, which must be a string. If you try to pass an integer argument or forgot the quotation mark at the end of the string literal, you'd get an error at this point in the process. The compiler finds the place in the code where you call a macro and loads the external binary that implements those macros. For each macro call, the compiler passes part of the AST to that macro's implementation. Here's a representation of that partial AST, so we can see it's this part right here that the macro will interact on, and so the macro will have no way of kind of like I was going to say like interacting, but maybe more in the way of sense of interfering. So the macro is constrained to this part of the code and cannot interact with this one. So for instance, this macro cannot change the let into a var, this kind of thing. Okay, so we were here. So a macro's implementation operates only on the partial AST that it receives as its input, meaning a macro always expands the same way regardless of what code comes before and after it. So this reproducibility, and is basically what was said in the chat. It's a pure function. What we have here is the exact definition of a pure function. It only depends on its argument, and it's even more than a pure function. That's interesting because the way it's written says that it's a pure function. It's also a deterministic pure function, but is it supposed to be, or is it still possible to use like randomness inside the macro to do weird things? I'm curious to see like is random code banned inside the macro or not? I guess you don't want your macro to use like random code. You know, it's like the macro from hell. In the macro, you get a number between like you get a random number, and if it's 0, you insert a fatal error, you know. So there is like one chance over maybe like a billion that your build is going to crash your app. That's basically like the macro from hell, or the joke that you shouldn't have made, basically. Okay, interesting. This limitation helps make macro expansion easier to understand and helps your code build faster, because Swift can avoid expanding macros that haven't changed. So there is kind of a caching system behind it, which makes sense because when you have a pure deterministic function, you are able to cache its results. So yeah, definitely it's not meant to use randomness inside of it. And yeah, Swift Roulette. I think the name Swift Roulette is really right. Like you can keep this in mind, like for April's Fools, like next year releasing the Swift Roulette macro, or the I Feel Lucky macro. That can be a nice one. Okay, so Swift helps macro authors helps macro authors having accidentally reading other input by restricting the code that implements macros. The AST passed to a macro implementation contains only the AST elements that represent the macro, not any of the code that comes before or after it. So it's sandbox not only like in the fact that the Swift code is in a module of its own, but it also only receives what it needs and nothing more. The macro implementation runs in a sandbox environment that prevents it from accessing the file system or the network. Okay. In addition to those safeguards, the macros author is responsible for not reading or modifying anything outside of the macros inputs. For example, a macros expansion must not depend on the current time of the day. So when I was saying randomness, depending on the current time of the day is in a way a form of randomness. Not the best kind of randomness, but it's still there are random generators that use the current time as their seed. Probably a bad practice, but it does exist. And yeah, I agree with you that this section, I think it's kind of like, when you're telling a child like don't run with scissors. It's there is a bit of this feeling. It tells you like all the mistakes you could make and why you shouldn't make them. Okay. The implementation of hashtag 4-character code generates a new AST containing the expanded code. Here's what that code returns to the compiler, so an integer literal in that case. And when the compiler receives this expansion, it replaces the AST element that contains the macro call with the element that contains the macros expansion. After macro expansion, the compiler checks again to ensure the program is still syntactically valid Swift and all the types are correct. Makes sense because you could return new Swift code that doesn't make sense in the context in which it is used. For instance, let me go back here, you could statically type this magic number as a string, and so once the macro has returned an int, then it's no longer valid Swift code. So let me go back. So when the compiler, I've said that already. After macro expansion, the compiler checks again to ensure the program is still syntactically valid Swift and all types are correct. Yeah, I've read it. That produces a final AST that can be compiled as usual. So this is the result AST. Honestly, they did a great job of explaining it very thoroughly. So congrats to whoever wrote this documentation. This AST corresponds to Swift code like this. Okay, that makes sense. In this example, the input source code has only one macro, but a real program could have several instances of the same macro and several calls to different macros. The compiler expands macros one at a time. If one macro appears inside another, the outer macro is expanded first. This lets the outer macro modify the inner macro before it's expanded. This makes me think, for instance, we could have now a macro that we apply to a closure and that would have maybe the weak self and the guardlet self inside the closure. Maybe we could have this Wikify macro that could be implemented. Maybe if I want to try implementing macro, that's what I can try to do in the coming days. Or if you want a challenge for implementing a macro, that can be an interesting challenge. I see a question in the chat. Let me see. Interesting to see how this works. Does the macro contain Swift code, which the compiler uses to generate AST, or does the macro generate AST that the compiler uses to generate Swift code? That's a good point. How is the macro implemented? Because if we make the analogy with Sorcery uses Stencil as a templating language, even though you can still use Swift, in Sorcery, but the default choice is a templating language called Stencil. So what is the actual language? I guess we'll see it just after in implementing the macros. So it's time for the answer. So to implement a macro, you make two components: a type that performs the macro expansion and the library that declares the macro to expose it as API. So what we saw before, the implementation and the declaration, I guess. These parts are built separately from code that uses the macro, even if you're developing the macro and its clients together, because the macro implementation runs as part of building the macros clients, so the sandboxing thing. Interesting, you say. Does it support recursion? Is it Turing complete? That's a good point, because macros in C don't support recursion because you don't have a call stack. They said that you can call other macros inside a macro, but not that you can call a macro recursively. That's a good question. I would tend to say no, because when you tell me something of a macro, I tend to think that it shouldn't be recursive, but I don't know. I would say no, but maybe it's not the case. So if someone can like verify it, or maybe they will talk about it later, or maybe if implementing a macro is simple enough, we can try to implement a macro just after we finished reading the document. But that's a very good question to ask. So to create a new macro using Swift Package Manager, you run a Swift package init type macro. This creates several files, including a template for a macro implementation and declaration. To add macros to an existing project, you add a target for the macro implementation and a target for the macro library. For example, you can add something like the following to your package.swift file, changing the name to match your project. Okay, we're getting into the more complicated part. And definitely we can see that the hard part about macros is not as much using them or understanding how they work, but rather implementing them. So interesting that there isn't a command in Xcode to create a macro, because you need to init the package. Okay, and so you would add this in your Xcode project. Okay, so the code above defines two targets: my project macros that contains the implementation of the macro, and my project that makes those macros available. Okay. The implementation of a macro uses a Swift syntax module to interact with Swift code in a structured way, so to interact with the AST. If you created a new macro package with Swift Package Manager, the generated package.swift file will automatically include a dependency on Swift syntax. If you're adding macros to an existing project, add a dependency on Swift syntax in your package.swift file. Okay. Replace the sum tag in the code above with the git tag for the version of Swift syntax you want to use. Depending on your macro's role, there is a corresponding protocol from Swift system that the macro implementation conforms to. For example, consider hashtag 4-character code from the previous section. Here's the structure that implements that macro. So we can see it's still it's a bit more complicated than the property wrapper. To give an example, and even it also feels a bit more complicated than your regular like result builder. And so you're saying the macros have to be in different modules because of the egg-chicken problem. If your module contains the macro to build the module, it's impossible to build it. So if your module contains, oh yes, exactly. If you have the macro defined inside your own project, then you cannot build your project, because to build your project you need to have that is a very good point. And you need to build the module, but you need the module to use the macro. So that makes total sense. That makes total sense. I was about to say in addition to it being sandbox, but I guess they could have. It was either that, or they would have need to create some kind of weird kind of target that you would add to your project, and kind of like an extension in a way. But creating a module of its own, I guess it made more sense. And also, since this is a Swift feature, I guess it makes it like more like a portable when you use it. For instance, for Swift on the server on other platforms. So our macro under the hood is a struct, 4-character code that conforms to the protocol expression macro. And I guess you also have a protocol attached macro. And so you implement this static func. So you can see it's basically, it feels like a result builder on steroid. And when I was explaining what result builders were when I was doing my SwiftUI training, I would say that you can see a result builder as a simple, small compiler, because the result builder kind of like turns control flow statements into data structures. And here it's even more of this feeling. So expansion is the name of the entry point of the macro, and so it takes as an argument a node, so which is some freestanding macro expansion syntax. So I guess the node is the part of the AST that we receive as an argument, and then there is the context, the macro expansion context. So I guess this is maybe where the arguments would be stored. We'll see. So inside, to get the argument, so it's node.argumentList.first.expression. So this is how you get the string argument. So this feels kind of like when you are parsing arguments from the command line without using a dedicated syntax. It's interesting that there isn't a better syntax for it also, because Swift has a framework to parse command line arguments, so they could have maybe kind of used it, but no, I guess, because the code has already been parsed into the AST. So I mean, you might have been able to build something similar, but it wouldn't have worked out of the box, I guess. So you get the argument like this. Then you get what's called the segments, and so the segment, it's okay. So the segments is the number, so it's the argument that's being casted as a string literal expression. Then you get the segments, okay, and then you make sure that there is only one segment, and you get the literal segment by casting that segment into a string. So it feels like a lot of code and a lot of introspection to get that value. What's interesting is that if this were to be production code, maybe like you would get a few comments on your pull request on the fact that you might want to refactor things. So this, I'm wondering, is it because they kind of cut corners for the example, or is it always that complicated? Because this begs the question of how do you implement a macro in a way that's maintainable? Because if you have more than one argument, this is going to get quite messy. But I saw that there were also ways to use other syntaxes. So we'll see how it works. And then we throw errors if something didn't work. So this is important, because when you have a compilation error, you expect the compiler to give you an insightful error message. But here, when you are implementing a macro, you are responsible for providing this insightful error message. So this can be also a challenge. Not only you want to focus on the happy path, but you also want your developers not to go crazy when they encounter an error. So these error messages are super important. And then you finally get the string from that literal segment. And for the results, so you call a function with what we could call the business logic of the macro. You give it the string, it gives you the result, if it was able to, and then you just return this. So you return this string, and so I guess then the macro takes care of mapping this into an AST. And so for character code, here we are back to regular Swift code. So it takes the characters, it turns them into their ASCII values, and it puts them into a uint32 by doing a bit shift to add the values. Okay. This was still a bit complex. Like when you see this, you see that implementing a complex macro is not going to be like a walk in the park. It's going to be a challenge. And like whereas implementing a custom property wrapper was a very approachable task, and even a custom result builder was still somewhat approachable, here it's much more of an effort, and I guess it's much more of some dedicated skills. So it will be interesting to see in the future, like are Swift developers going to adopt creating macros a lot, or is it going to be just a few library developers that will focus on gaining this knowledge? Because there is definitely a stronger barrier to entry here than to implement a property wrapper, and even the simplest version are arguably more complex than a property wrapper. So let's see the explanation. So the 4-character code macro is a freestanding macro that produces an expression. So the 4-character code type that implements it conforms to the expression macro protocol. The expression macro protocol has one requirement, an expansion of in method that expands the AST. For the list of macro role and their corresponding Swift system protocol, see attach and freestanding in attributes. So we'll check this out just after. You know what? Let me open them. To expand the 4-character code macro, Swift sends the AST for the code that uses this macro to the library that contains the macro implementation. Inside the library, Swift calls the 4-character code .expansion of in, passing in the AST and the context as arguments of the method. Did we use the context actually or not? I think the context was never used actually in this example. The implementation of expansion of in finds the string that was passed as an argument to 4-character code and calculates the corresponding integer value. So that's what we saw. Interesting. Will there be a macros marketplace? Because I guess yes, maybe you might want to have a business model like selling good quality macros. That's a very good point. Let's see where was I? I think I was here, yes. In the example above, the first guard block extracts the string literal from the AST, assigning that AST element to literal segment. The second guard block calls the private 4-character code for function. Both of these blocks throw an error if the macro is used incorrectly. The error message becomes a compiler error at the malformed call site. For example, if you try to call the method as hashtag 4-character code, that's interesting. So if you pass in an expression that needs to be computed, then you would get an error. So Swift is not going to evaluate the expression beforehand. Whoa. This is a bit like this breaks a lot of preconceptions and preconceived. I mean, not preconceived, but invariants that we always assume Swift will work that way. Like if you pass in an expression to a function, it's being evaluated before the function is called. And so here it's very different. So calling a function is different from calling a macro, because a macro, when you give it as an argument, the argument is not as much the expression that you give it, but rather the piece of code you've written. And so if your code is an expression that needs to be evaluated, it will not be evaluated beforehand. So this is very important to understand and quite confusing, because you make the call using the same syntax, using parentheses, but calling a macro is not the same at all than calling a function. And I didn't expect this, but I guess it must make sense, because probably it opens up the way to more like oh no, I know why it makes sense. It's because you could pass in an expression that might not be able to evaluate at runtime. Like if you pass in an expression that uses an argument that will only be known at no, let me redo it. It's because you could pass in an expression that cannot be evaluated at compile time. So imagine instead of AB plus CD, because here we still have two static strings, you pass in AB plus some value that will be gotten from a text field in your app. There is no way at compile time to know what the actual value is, and so the compiler wouldn't have a way to turn this into the final string that it would be that the expression would result in. So it makes sense that it's not evaluated, because we are at compile time and not at runtime. But I'm sure we can expect a lot of people getting confused by this. I guess if they had wanted to be not to be correct, but to be more more clear, maybe they should have used something else than parentheses for calling something. But I mean, it's so common to use parentheses to call something, and it's not like there are that many other symbols possible. But that's a very interesting insight, that calling a macro is very different than calling a function. Okay, last paragraph. The expansion of in method returns an instance of X syntax, a type from Swift syntax that represents an expression in an AST. Because this type conforms to the string literal convertible protocol, the macro implementation uses a string literal as a lightweight syntax to create its result. All of the Swift syntax types that you return from a macro implementation conform to string literal convertible, so you can use this approach when implementing any kind of macro. So I guess here we could just like return like a code that is we can write code and put it in a Swift. No, we can put code in a string and use string interpolation to inject values. And I think because I picked at the example just below, this is kind of like what you could do, I guess. No, it was still using strings, but not for that. But I saw an example of people using this approach of returning Swift code that was put inside a string. So you lose type safety inside the macro, of course, when you do that. So Frank, you're saying in this specific case, it must be a string literal, but some macros can be more flexible with expressions. That's interesting. Let me find where it was. Okay, so I guess it's because here we were explicitly looking for a string literal expression syntax. And does it mean that there is an option in the macro to say whether or not you want the compiler to try and evaluate the expression? That's something to look for. Okay, I see a few other comments. So you get this AST because your macro sees the AST the compiler sees before doing any processing on it. It would probably be possible to add more complex parsing logic that will evaluate these expressions. And I guess you could also add this logic, I guess, in your macro if you were to need it. A very good point. How do you test macros? I would say kind of by doing some kind of snapshot testing in a way, where like I mean you give it an input and an expected output, and you make sure that it generates the same thing. Yeah, I'm thinking that a snapshot based approach could work quite well here, because I guess you can only, I mean, you could test this independently because it's just regular Swift code, but this part here, I guess, yeah, you need to give it some Swift code to test it. And I've seen like some compiler bugs usually, like because you can, because of the it's hard to phrase this. Basically, you can write Swift code that is valid Swift code that you would never write normally because it just doesn't serve any like a real world purpose, but you can write it, and this kind of code tends to generate bugs. Like if you want to find weird bugs in a compiler, you generate code randomly, and usually you get code that is valid, but that might either not build or crash your compiler because like your compiler might have assumed that this would never happen, even though the syntax, the grammar doesn't explicitly forbids it. And you were saying this is similar to at autoclosure. The thing you pass is lazily evaluated, and it can be surprising. That's true. That's true. But there is one key difference: is that with autoclosure, indeed, you would get the lazy behavior, but you were not able to introspect the content of the closure. And here it's different because you get the full expression, and you can introspect it. You can walk through its tree syntax. So this means also that you could pass an expression to a macro and expect the macro to add things around this expression also. So this might also like enable some interesting use cases. Umberto, you're saying in the session about macro, they wrote tests for the macro. Interesting. I didn't watch that session, but I should watch it in the future. And so you were saying, Frank, actually you think it's not a string, it's a string literal used to create a declarative syntax. So yes, I think you refer to this thing here, and I guess you're right. It's not a string in the sense that it's a specific kind of string that is defined in your code, and that the compiler can take it and reason about it, in the sense that everything about this string is known at compile time. If this is what you were saying. you can write macros that generate tests for what was generated. I want to mention this because one of the cool use cases I always liked about Sourcery was actually generating tests. Like for instance, if you do dependency injection with Swinject, since Swinject is not compile time safe, so you can forget to inject something, and then at runtime you will either retrieve a nil from your dependency container, or you will get a crash if you were force unwrapping. And so what I used to do in a previous app was to generate tests using Sourcery that would automatically attempt to resolve every dependency in test functions. And you could absolutely implement this with a macro. Okay, before we move on, I wanted to see these two links. So, okay, so here it's dynamic member, wait. I'm not sure if the links are correct. Oh yeah, no, okay, freestanding, yeah, it applies the freestanding of a macro, but I was looking for the protocol that you need to implement for an attached macro. Okay, interesting to see that they are tested by comparing multi-line strings, and so my hunch about snapshot testing wasn't that bad. All right, we're getting close to the end of this document. So developing and debugging macros. Macros are well suited to development using tests. They transform one AST into another AST without depending on any external state and without making changes to any external state. In addition, you can create syntax nodes from a string literal, which simplifies setting up the input for a test. You can also read the description property of an AST to get a string to compare against an expected value. For example, here's a test of the 4-character code macro from previous sections. So actually, it was talking about the testing just after. So here we assume this is a test, and so we create our simulation of Swift code using this source file syntax type, and then we can use a literal string to initialize it. Okay, so this is valid Swift code that is turned into a source file syntax. And then we can create this basic macro expansion context. So I think what we are doing is that we are creating the context that the compiler would pass to the macro. And so here we create so here it was just the source file, and here we create the expansion context giving it the source files. Okay, so we have the source and the file actually, so we have these two things. And then we have the transformation, so we do source expand this macro in context, and so we give the name of the macro and also the type that implements it, and we would get the result, and so we would compare that our expected is indeed equal to the description of the transform source file. Okay, this is pretty cool. We've spent a bit more than 1 hour covering this document. So how about we try to implement a simple macro before we end? So let's see if I can make this work. First, if you have any idea about the kind of macros we could implement, please give me a suggestion. I was thinking the most basic one, which is like to do a stringify. So you pass in some expression as code, and it turns it into a string. Let's see if I can make this work. So they were saying you need to run this command, and I wonder if you need to do it inside your Swift, inside your Xcode project or not. So let me see. I'm going to open a terminal. I'm going to put it so that you can see it. So I'm going to cd into my desktop. I think I have called it discovering Swift macros. Okay, so now I'm going to paste the command. So let's see. It's doing a few things. Error, the value macro is invalid. for, oh, wait, the value macro is invalid for the type. Is it because maybe, maybe if I'm going to look at Swift, maybe I don't have, let me do one thing. Let me go in Xcode, in locations. Okay, I'm going to do Xcode select, the Xcode select thing, so that, can I put this outside of the live stream? You never know. All right, so now I'm using Xcode 15 for the command line tool. Let's see if it works better. I might need to restart the terminal. Oh, didn't even need to restart it, and it worked. It created everything I needed. Awesome, perfect. I'm always a bit scared of running like unknown command lines during a live stream because you never know what's going to happen. So now let's go back to Xcode. So if I do show in Finder, we can see that things have been added, including the sources and the package.swift file. So here it's like, can I just add the package.swift to my project? Let me add all of these things. It is going to, no, I don't want to add them to my target right here. So I'm going to just add this package.swift. Okay, now I get build failure, so because import package description, and I'm so not sure whether it's whether this is a placeholder or not, actually. Do I need to do something else inside inside my project? If I do package dependencies, I haven't set up things using SPM that much, so I don't know by heart how you're supposed to do it. I guess what I should do is that I think I should put this code into no, the package.swift. It shouldn't be inside. I've put it inside my app, but I think this was a mistake actually, and I think I should have like I'm going to just remove all these files that I have added, so the source and the test, and I want to add a package dependency to my project. Yes. Yeah, I think this is what I want to do. So adding a package dependency. Okay, so yes, I'm gonna want to create my package, and then I'm gonna want to add it as a dependency. So I guess if I go back, where am I in my terminal right now? Did I close it? I think I closed it. Yes, I closed it. So I'm going to just redo the two cd, and I guess I want to create. I'm going to make a directory here. I'm going to call it macro, for instance. Oh, yeah, macros like that. I'm going to cd into this macros directory, and so I will and then I will create the package inside this one. And so now, if I add a package dependency, because I want a local package, add local here. Okay, I can go here, and I guess I need to select just this. Okay, seems to work. Whew. Yeah, this is when you can see that I'm more used to creating small snippets of animated code than adding packages to Xcode. It's not my main use case for Xcode. Okay, hey, interesting. This is what you were mentioning earlier, Frank, I think. Okay, so I have my project. Does it still build? We have many more files. That makes sense because we have all of these things. And if I want to edit the content of my macro, I wonder, okay, build succeeded. I'm just wondering, am I allowed to change something here? Yeah, since it's local, I guess I can change something. I'm just looking to make sure, because here, yeah, if I try to write something, I don't know if you can hear it, but I have the little sound that says, no, you cannot do this here, but since it's local, you can do it. Okay, perfect. Oh, actually, I was talking about Stringify, but look, this is the default one. So I've heard people talking about Stringify on Twitter, but I guess that was why, because it's the default one. So here we have the declaration. Here we have the main, okay? And here we have the implementation of the Stringify macro, all right? And this is what it does. So it gets the argument, and then with the argument description. Okay, and let's try to use it in the main code. So if I do print, so hashtag stringify like this, maybe I need to import something. So let's go back to the package.swift to see which one is the library. So it's macros. So I should do import macros. And if now I do like, you see, I do let A equal 1, let B equal 2, and then I do A plus B. Yes, we have the good syntax coloring. Okay, it seems it should work. Let's run this. If it works, it's going to be so much more a success than yesterday's live about Swift Data when it came to actually executing things. So there is an error, not valid for use in process. Oh, there are code signing issues, it seems. We have code signing issues with library not loaded. Let me see if I can fix it easily or not. So if I go into my code here, so it's signed with my personal team, and it seems the issue is with this code here. Can I do something about it here or not? I'm just going to try and clean everything, just because like you never know with software that is still in beta. I was so looking forward to seeing the result. So when you do command click, you are then redirected to the declaration of the macro. And we see a warning here. External macro implementation of type macros, Stringify macro could not be found for macro Stringify. The type must be public and provided via. Do I still get the error or not? It seems the warning like went away. Okay, it's still crashing. So let's try and analyze the error message a bit more. What does it say? So library not loaded macros. No such file. Not valid for use in process. Map file has no team ID and is not a platform binary. Signed with custom identity for ad hoc. So it seems to be either a code signing issue or an import search path issue. Let me see, is there something that I can do like for the framework that I import? I don't know if there is a configuration I need to have, because I know that when you import things, sometimes you then need to like resign, but sometimes there is something to say whether or not you want to resign them. But or maybe here I have macros and macros client, and maybe I shouldn't have like the two of them. Maybe I should only have like macro client. Maybe, I don't know. Yeah, because this macro client, it feels like an executable. So this feels like this shouldn't feel like it's something that should be imported inside my my macOS app. So let me get rid of it. Yeah, you know, when I imported yes, so I now I get why. It's because when I did the add Swift package, I checked every box to import everything I could import inside my my app, but I should have thought about it a bit more. And so now we can see that Stringify did work. And what's interesting is that we seem to have the result of the evaluation, because 1 plus 2 equal 3. Just to see, I will change it to 4 just to make sure. Okay, so this is what's happening. And so inside inside the macro, so it produces a tuple which evaluates the expression. Okay, so I guess what is returned, let's see what is returned. So because it returns Swift code, it returns the argument, so the first thing, and then the argument description. What's interesting is that I guess it's because the argument could be evaluated maybe at compile time. Because let's try something. Let's here do something like int dot random int 0 5, for instance. Is it still going to run or not? It was still managed to say 8, and so it should give a different value every time. Okay, so it's still able to evaluate it like, but does it mean that now int.random is evaluated at compile time and not instead of at runtime? It could be the case. I have an idea. We're going to use timestamp to try and measure like when this is happening. So let's see what we could do. All right, I know what I want to do. I'm going to create a task. So I'm going in this task to get like the current. I can expand the macro at the call site. That's a very good point. Let me do that to see what's inside of it. Okay, so it does A plus B and then A plus B. Okay. Okay, so actually it's still. Oh, all right. I think I get it now, because when it says argument here, so it's the argument in the sense that it's the Swift code. So it just returns the Swift code. Oh yes, so what it returns is a tuple. It returns a tuple with, in the first element of the tuple, the expression A plus B, and then in the second element, a string which contains the Swift code, which contains a string representation of A plus B. So I guess it's still evaluated at runtime, except that now the expression has been moved to a tuple, because in this code, I don't see anything that seems to evaluate the code at compile time. But let me run my little test to be sure of it. So I'm going to do something like current, more like time before equal date, okay? Then I'm going to do let expanded macro equals, so hashtag stringify time before. Okay. What I want to do is put a sleep, basically. Like I want to put a sleep between the moment where this is. So yes, here it's just turned into a variable. Then I will do a print of expanded macro. And what I want to do is a task dot sleep. Is it like this? Yeah. Let's sleep for 1 second so that we can, or even 2 seconds, so that you can see a big difference in the date. Okay, and now let's print a few things. So let's print like time after sleeping. And so here I'm going to put just like the time right now. Yes, here I need to do like try a wait. Okay, and then I print the expanded macro. Here it's not happy because Okay, it seems that there are things. Okay, the errors went away. You're saying, Frank, let me display your comment. You can replace stringify a plus b with stringify random if you like, still evaluated at runtime. Maybe I should have started with that. Let's see what this is going to do. Like, I'm not even sure it's going to do what I wanted. Plus, because the program ended, it didn't wait for the task to finish. So I need a way to wait for the task to finish. Can I do this directly in the top level code or not? Yes, I can. So actually, I was doing like my weird like task thing, but I didn't even needed to do it. And you're saying I should do the print time before. Yes, I should do it before. My thinking was because we have the time before here, but yes. So let me get this and put it also before. So time before sleeping, and it's going to be this one because we can assume that the time it will be like mostly the same. Yeah, you're right, Frank. I could have awaited on the task like dot result, for instance. Okay, so it's sleeping. So before and after sleeping, we do see the 2-second difference. And when we see, so here, we see that it was evaluated. I think maybe I wanted to do the expanded macro after sleeping. Maybe that's what I wanted to do. To see like... Honestly, I'm not even sure what I want to do. It's so confusing. It's so confusing. Okay, so I give it the time. I give it the time before, but actually this is evaluated. Damn it! What did I want to do? I wanted to. Maybe I should have done something like that to see like. It's so confusing. I cannot even like remember what I can't put into like a clear thought what I want to do. I want to see whether or not this is evaluated inside the macro or after. So when the code is expanded or when it is actually evaluated. So if I do it here, yes, if I do it here, okay, I think I'm starting to get my train of thought together. So, all right. I call my macro here and I pass as an argument the date. So this, the result of the date isn't known until the date has been called. And so the question is, will the date initializer be called when the macro is, but then it's going to be into expanded macro. Every time I try to think about it, I feel like I'm losing my train of thought. Because if stringify, because the result of the expanded macro, it's not new Swift code, it's a date and a string. So okay, what I was saying, like, doesn't really make sense. Because otherwise it means that I mean the question I had like will the date be when I have compiled the code or when I have run the code? That's basically the question I was thinking. But so for instance, if I build the code right now, maybe run expanded macro twice too. That could be a good point. If I run it twice, but it will be because if I run it before You're saying maybe assign the stringify result to a variable name and print that. It will maybe make it more clear. Yeah, that's kind of what I'm doing here because I'm storing it into expanded macro. But actually, the expanded macro is not really the expanded macro because the macro returns a tuple with a value of type t and a string. And so then, yeah, expanded macro is a let constant. You're absolutely right. So it means that when this code is run, yeah, I guess if I want to have my answer, I need to check like the time. So okay, so it's 9:34 for me, and so I'm going to build my code. So I've built my code at 9:34. If I run it, it's going to say, yeah, it's because of the time difference, but it says 34. And if I keep running it, yeah, we can see that the time does increment. So it's definitely not evaluated at compile time. It was much easier to actually see this than this whole weird experiment I was putting together. But okay, so this is going to take this date, and it will basically, like, this is going to turn it into this, like that. And if I show the expanded code for the macro, so yeah, it's exactly this. So, and indeed the date is not evaluated. So if you just joined in, Ryan, since we're getting close to the end of the live, it's going to be a bit hard to catch up, especially on a topic like Swift macros. But don't worry, the replay will be available as soon as the live is finished. Okay. You know what? Let's try to do one last thing. Does someone have an idea on a kind of interesting macro we could implement? Something a bit more complex than stringify, but still simple enough and that has value. Something that you could use like in real life code. I'm trying to think the kind of stuff that you write as a helper. I don't know, we're going to do something, I have an idea. It's not the weak strong dense. I think it might be a bit ambitious, especially since I don't know the AST syntax that much, but I'm thinking, so it's not a good practice I would recommend, but you know, sometimes when you have a string, you need to test whether it's nil or empty. You can do this with an extension. Of course, you can do this with an extension, but we could try to make a macro that takes a string and adds all of the tests that you need in order to what I'm saying is that let's imagine that you have maybe string, so it's going to be bool.random. It's either hello world, it could be hello world. What I'm about to do is going to be absolutely disgusting, but I'm going to do another bool.random, and it's going to be either hello world or the empty string or nil. And so then you would like to write if maybe string is different. You know, you would do if let maybe string different of the empty string, different of this, and then do something, and so have a macro that generates this. I feel this is kind of nice. Yeah, automocable, I ain't gonna lie, it's a great idea, but I don't have the knowledge of how to handle the AST. Plus, I don't know if you've ever looked at the stencil file for automocable, but when you think about it, you're like, oh yes, it should be rather straightforward, and then you look at the file and you're like, whoa, it's much more complicated because there are lots of edge cases, like how do you deal with closure arguments, how do you deal with closure arguments that are meant to provide data, the ones that are more meant as completion handlers. So it's a big topic, but you could definitely implement AutoMockable with a macro. And actually, it will be interesting to see like if projects that use Sorcery today will move on to using AutoMockable, using macros instead. Okay, so let's try and implement this macro. So what would be its name? It would be, I guess, so there is empty. Yes, you're right. Yes, you're absolutely right. You can do something like this. Absolutely right. So you could already encapsulate this in a clever extension on optional where the wrapped type is a string. But let's try and build this. I'm trying to find a name for it first. So what would be the name? I guess it would be I don't know, like because there is a binding, like bind if not empty, for instance. It's not the best name, but at least like it should. So the is ID is kind of nice, but I don't want it to be is because if we go back at the code, there is kind of a side effect. We not only do a test, but we also create a conditional binding. So it's like kind of like if not nil and not empty, or it's like yeah, I'm going to call it bind if not empty. We'll see how it's going to go. And indeed, I'm aware that there are easier syntaxes than using a macro for this, but I want to try this one for the macro because it feels like approachable and doable in the like 20-30 minutes we have left together. So let's implement this as a public struct. So I'm going to call it bind if not empty. So it's going to be an expression macro. Let's see also how much the compiler can generate to help us here. Okay, it can generate, so wow, it seems like it added a lot more things. Yeah, because it didn't use the it's interesting. It didn't use the sum syntax, but rather generics. But we are going to use the sum syntax because it's going to be much more readable. But it's interesting to see that the compiler by default doesn't use the sum syntax and would rather introduce a generic argument. I guess since this is like the more like well the more generic, but in a sense when you use sum, then you can no longer refer to the generic argument anywhere in the function. So this is kind of a restrictive case. So it makes sense that it's not what is used by the compiler, but that's interesting to see that the compiler goes for the most complex solution, or the compiler, or maybe just like the fixit, which might not be part of the compiler necessarily. So here, what do I want to do? I guess as an argument, I want to make sure that I have something that is oh yes, they put a breakpoint. That's a great idea. I'm going to display it so that people can see it on the replay. So in the WT session, they put a breakpoint in the macro and it PO on the parameter to help you figure out how you want to type it. So that's a great idea. We are definitely going to do this. So for now, I'm just going to add the necessary declaration in order for me to use my new macro. So I add it to the providing macros. And then here I need to also add the declaration for it. So it's going to be a freestanding expression. So public macro bind if not empty is going to take as an argument. So here, can I force the fact that the value must be an optional string? We'll see if it works. And what should this return? I guess, I mean, this is going to return like you see here it returned like a value, but in my case it's more going to return Swift code because the let syntax, I need to have a let. So let's see. Maybe I will just do something like this for now. Just say that I don't know, like if I go back to the option set method, it's so different, the option set, because it was an external, but it did this. So, okay, we'll see like how it's going to work. So I'm just going to do this, and then I do, so it's an external macro, and for the module I can just give the same name. And for the type, so here is going to be bind if not empty, and then I can turn it as a string like that. Okay, so now let's try and use it. So I will just use it outside of an if statement for now. So I could do bind if not empty and pass my maybe string. Okay, build failed here because. Oh yes, because I still have this code right here. So I guess I should just do nothing. If I do nothing, what happens? It also fails, because I guess I should always return something. So what can I return to be a no-op? I guess I can return just an empty string. It's still failing. Because it didn't return anything. I mean, I could just return the argument. So I could just get the argument like this, and then just return like the argument like that. Does it work or not? It cannot find argument. Oh, wait. Still build failed. Cannot convert value of type string to void. Yeah, what you're saying is right, is that, but you know, the way I would have seen the call site would have been something like this, and then here maybe string, you can use it like that. So, but maybe actually what I'm trying to do here, like maybe it's possible, but maybe not with an expression macro, because in a way when I do if like this, it expects an expression, and this returning like a let, a conditional binding, might actually not be possible. So maybe what I picked as my simple example was not as simple, or maybe not even doable. So you're saying I need to return string instead of the empty. So I'm going to return the string, but actually what I'm returning is not really the I mean, yeah, I guess it's a string. Yeah, I guess it's a string. And so, but I wouldn't be able to use it, you know, in a if like this. So actually what I'm doing, okay, I guess it still makes so expression is unused, all right, that I'm okay with it. But where does it say that value of optional type string must be unwrapped to a value of type string? Where do I have this error? Because this does nothing. Oh yes, because I'm not doing anything actually. Yeah, actually what I want to do is not clear at all, because I'm saying, okay, what I've written for now is that this returns a string, but what happens like when there is a nil value, what do I do? it's more like returning a default value, but I wanted to return a binding. But yeah, I guess this isn't what this isn't the right example. I'm trying to see if I can come up with another example that I could implement to finish the live stream. When you have a let's see, what could you use a macro for that you cannot use a function today? You're saying I can return a bool. Yes, you're right. I could return a bool for now, indeed. Let's do that. It still won't give me like a binding because I won't be able to use the variable in a way, but it could return me indeed like a bool, indeed. So the name wouldn't be good, but what I would be able to do then here would be to do. So it's similar to how they did the hashtag URL. Yes, the hashtag URL. That would have been a great example, even though you need to know like the regex for a correct URL. So it's not as simple as it seems, but trying to come up with something that would be usable, that would make sense. Yeah, exactly. For the URL, it's a static string, so you can like use it at runtime. What cannot be done? So you're saying like if I return here something like this, so let and then with the rest of the code, you know what? Let's try it. Let's see what it's gonna do. So it was something like that. So okay, let me write the code here, and then I can just put in argument where I need. So it would be like that, and also here. Yeah, because the part that is not clear for me is when you say that this returns a string, is this a string, or is this a Swift code that is in string form? I don't know if you see what I mean by that. So let's try and build this. And so if here I do if, okay, it seems to work, like print maybe string. Okay, build fail, but when you look at the code being expanded, it seems not that bad. It seems not that bad. I might need to use a generic argument. Cannot convert a value of type string to expected condition type bool. Because since we are in a if, I think it starts parsing I guess that when the compiler sees the if but with no let afterward, it starts to parse it as a condition. I mean, as a condition and not a conditional binding. And I'm not sure that a macro can make it go back on that decision. Frank, you're saying what's passing is always an expression. So I guess, yeah, that might be like, I guess this might be a case where we would need the macro to maybe to include the if. So you're not returning a string, but an AST branch. That would make sense. But I think that because the if is outside the macro, then the macro, the compiler has decided that this is not a conditional binding because there is no let, and you cannot make it go back in the on his decision. And I see, yeah, Ryan, you're saying let's include the if in the string code as well. That's exactly what I was starting to think. That's exactly what I was starting to think. So let's try and do it. Okay, so now I would get rid of it. Still build failed. Extra trailing closure passed in macro expansion. Let's see. Can I still expand this? No, I can no longer expand it. You know what? I'm gonna try and... No. I want to comment this code and see if I can expand it. Okay, so we can see that it seems to be working. But it seems that then it's kind of like, I don't know, kind of like if it understands the rest as a trailing closure, you see? Because it says extra trailing closure passed in macro expansion, so it doesn't understand that this is an if, and then this is the code inside the if. But you have to pass the closure to the macro. Okay, so as the second argument. Okay, what's interesting is that at least we learn about the limitations of using a macro. Also, this is not syntax that I would recommend because it's terrible what I'm doing right now. And so the second argument, let's see. So I need to add it here. So I have my value, and then I have my my handler, we could say. So the handler is going to be something that takes as an argument a string and goes to void. Let me make it so that it's more readable on the live stream, like that. Frank, you're saying the macro will be expanded as an expression eventually, and it needs to be self-contained. So if you return the if in the expansion, you need the closure as well. Yeah, that makes total sense. Okay. And so here I will do my, so I will turn this into a multi-line string now, like that. Okay. And so here I will actually be calling, so I will have like the argument, and the closure will be a second value. So it will be let closure equal node dot argument list actually of one dot expression. Maybe a let isn't needed actually. Yeah, because actually it does a fatal error otherwise, but since this would have crashed anyway. Oh no, because you still get like the good error message. Yeah, no, this is an extension that you need to add to your project. You know what? I'm going to do it the quick and oh yes, last. You're absolutely right, because since there are only two elements, yes, you're absolutely right. Last, let's do it like that. Okay, and so here, I guess what I do here is that I call the closure, and to call it, I pass in the argument. Does this work? So it still says build failed. Contextual type. Oh, okay, because since it's a closure, I need to do something like that. So yeah, maybe it will work. It will lose a lot in interest, for sure. It still says build failed. Why? Expansion of macro in expansion. So expected macro expansion to produce an expression, and it didn't. You can remove the string from the closures parameters. That's interesting. Maybe I can indeed. But then, like how will Swift be able to link the symbol I'm using in the closure? let's see, but I'm going to make the change. So here I go into an empty closure. So I just do closure like that. Oh, wait, actually, yes, what I want to do, okay, because this is so confusing. I want to do closure like this, and I want to use it. Now, here I want to get rid of this. Still build failed. Still build failed. I guess I have some extra. I mean, this should still be like valid because you still have an extra scope. Or maybe you need to do like. No, I think you need to have the do keyword if you want to do that in Swift. So let's go back to the code of the macro, but we are getting there. So here there is the if, and because the closure. Okay, so you know what? Let's do it like this. Still build failed. I mean, this time it seems like it should be correct. Let's see, like if I copy this code and I copy paste it, I want to see if there is an error with this code. No, this code does work, but for some reason, the macro here doesn't. Oh, wait, the message says expected macro expansion to produce an expression, and here it seems like it's not an expression, it's more like code, it's more like a statement. So maybe that's why. Maybe that's the reason why. Do I need to change something into the way? Maybe it's this thing expression here that I need to change. Let's try and see what are the other possible values here. You're saying declaration? Seems like it doesn't exist, but it seems like a good idea. But I would like to see how do I find the source for this? Or you know what? I'm going to look to go back to so freestanding expression, and I would like to see because they were saying like all the list of potential things we can use. So here, this is for attached, but me, I'm looking for freestanding. And freestanding, so they say I applied the freestanding attribute to the declaration of a freestanding macro, but what are the arguments I can pass to it? I'm gonna look for it there. If I write freestanding, maybe. There are only two, expression and declaration. Okay. I'm going to go back to Xcode. Maybe I just made a mistake. That's so weird because it even like suggests it, but you see it doesn't color or anything. That's why and it seems it doesn't find it. Oh, maybe also because here then it should be like a declaration macro. I don't know if it's the issue, but anyway, like I should do that. Apparently, I don't conform to the right stuff now. So it's a different one. So it's expansion. We still have node context. And for the return type, it returns a decl syntax. Okay, so let me move it like that. Okay, let's see. It still says that it doesn't conform to a declaration macro. So I have the declaration syntax. Maybe this doesn't conform to the declaration syntax because here I have my node, I have my context, the context, so it's macro expansion context here, freestanding macro expansion syntax, so it's not linked to the fact that it's a decl syntax. Oh, it returns an array. Okay, so that's why it returns an array of declaration syntax. All right. And now I need to return an array, which I don't. Can I try just like lifting this into an array and hoping that it works? Or is it more like complex than that? Okay, so if we try to expand this macro, let's see, let me get rid of that. If I do expand macro, yeah, we get nothing. I'm going to try and put a breakpoint inside the macro like was suggested. Okay, this time it still seems to work, but expected macro expansion to produce. Why does it keep saying that? You know what? I'm going to clean everything. Let's see. I would really like it to work, but we still get a build failed, but in a different place. Statements are not allowed at the top level. Freestanding macros are not yet supported in script mode. Okay, so it's because I am in this very special file where it's kind of like a playground. So it might not be because my code is wrong. Let's see. If I just create a function, my function, and I move my code inside of it, let me get rid of this also. Then I just keep, I move this here, okay, and then I just call my my function. Let's see. Build succeeded. Let's try to run it. Okay, I still have my stupid code above, but this time it said hello world because I guess we were in that case. And let's see. And other cases it did nothing. So it seems we have succeeded. And maybe let's try and remove the closure. Now, can I get rid of... so first I could use trailing closure syntax to make it a bit better. But I'm wondering if I could do without the closure. No, because the macro needs to know about whatever code is after, because otherwise, yeah, no, if I do like an if, I just want to see like if I go back to my previous like strategy of doing things like that, and this time I keep it being like a declaration and not an expression, I'm wondering if it would still work. So you know what? I'm going to keep this around because I might need it. Exactly, that's what I was trying to do it without the if. So I'm still going to keep my multi-line string, and so here I would return let argue. So basically like this thing here. Why am I writing everything again? Just like that. So it would be like this. And so in the code, I would do something like this. Okay. Yes, no, cannot convert value of type string to expecting. Oh, because also there is the second argument that it doesn't know about. So that might be why. So I need to update here and get rid of this second argument. Now let's see. Yeah, no, it still says you cannot convert from string to bool. So no, doesn't seem to work, or at least not that way. But I'm pretty glad that we were able to make it work by the end of the live stream. I wouldn't have expected the issue around the fact we were in a top level function, to be honest. I kind of understand why it wouldn't be necessarily compatible, but I'm glad I finally managed to get an error message that put me on the right track, because otherwise I think I would have never like gotten it. Just want to make the code work a bit more, because I would like to put the code on GitHub afterwards. So why doesn't it work now? Because I have argument, do, and closure. And now it says, if I try and expand, if let do maybe string. So it's here there is a problem because it's not the closure, it's the argument. I think it's because of I think what you're saying. It's because when the AST is parsed, I think if there is like when it reaches an if, it looks at the next symbol, and if it's not a let, then it considers that it's just like a conditional, and if there is a let, then it considers that it's something else. So you're saying remove the do. That seems logical, but I'm wondering why it worked before. What did I forget to change back in my changes? Because why does it say maybe string here? Whereas, wait. So argument, closure, argument list first and last. Could it be because I don't have the second argument anymore? I've put it back here. You know what? I'm just going to do, before I try to remove the do, I'm just going to clean because it might be a weird cache thing, and otherwise I could indeed remove the do. I guess maybe I could have the if be inside this. But yeah, it seems to be a case where first equal last, definitely, and I think it's because of like of a weird caching or something like that. Because let me see, like I'm trying to, when I put the code here, I didn't do anything else. Yes. And when you expand the macro, so it still doesn't get the maybe string. I guess I must have missed something somewhere, because here I have my macro, okay, declaration, bind if not empty. So there is the value and the handler. I put it back. And so here, and what if I go back like this? Okay, so now it works like this. So it's kind of funny that when I don't wanted a trailing closure syntax, it wouldn't get it. But now, like it won't get that this is a closure passed to this thing. And so let's see. If I remove the do, I don't think it's going to change anything, because the issue isn't as much. I mean, it's going to do something, but not what I want. If I remove the do and I expand, you can see that it just like uses the maybe string as an expression. So it might be the trailing closure, but I'm going to try, you know what? One last thing. So it's to have only like only this part. So I'm going to remove this. So this way I only have if let part. And so the closure here is no longer used. Here I will no longer take the closure. And now it says, okay, it's really like the trailing closure. It's when I don't want it to see it as a trailing closure, it sees it as one, and I would like it to, it doesn't. All right. Let me put the code back in a working state so that I can finish the live stream and have everything that works. Let's see. And when you expand, yeah, now it does the maybe string. So that's not great. And when I do it like this, then it does bill fail, because there is no longer the do keyword to say that you need to execute this scope. Okay. Is it back to working? It's back to working. Okay. What did we learn? I guess the main thing that we've learned is that macros are a difficult. Maybe I shouldn't say difficult, but they are a skill that you need to learn, and it's definitely not obvious writing a macro. So I guess the lesson here is that if you want to write a macro, make sure that you really need it, and that there isn't another way to implement what you need, because writing a macro that will work in the correct case and that will provide insightful error messages when used incorrectly is definitely a big job, and in a way it's more of a compiler engineer job than an app developer app engineer job. It's good to see Swift supporting it, but I could very much see this as a pitfall of developers trying to like over optimize their code base and just like going down the rabbit hole and losing tons of time. I'm just seeing here it says expression of type string is unused. So should I get rid of this thing here? Okay, apparently I can get rid of this, and I should get rid of the warning then. It still says that expression of type string is unused. Okay, that one is still a bit weird because there is no unused expression. All right. You're saying most use case for package from DB vendors, for example, that will generate entities for you. Yeah, exactly. And that's exactly what Swift Data does with the at model macro, or what the at observable does to generate observable entities. So yeah, I would say I think twice before using before creating your own macro. However, knowing how macro work on the big picture, I think is still important, because even if you won't be creating your own macros, you will be using macros. Maybe not the one made by third-party people, but the one made by Apple. So it's important to have the knowledge of how they work, so that when you have an issue, and we all know that you will have an issue at some point, you know where to look at. You have a big picture idea of how things are working, and that's very precious when you need to debug an issue. So yeah, I would say the document that we have read together, like share it with your colleagues. I feel like it's a good level of information to feel like comfortable using a macro, and knowing what you're using, and also knowing the complexity behind it, because I kind of feel that there is nothing worse than not being aware of the complexity behind something, because it might make you, too very enthusiastic to use it. Whereas if you knew like all the things that could go wrong, maybe you would have been like a bit more careful, and you would have been like, okay, maybe let's wait a bit, let's think it twice, or just let's do it like incrementally in order to avoid potential issues. But anyway, I think that's all for this live. I'm really glad with how it went. I feel it went even better than yesterday with Swift Data, because we had the tutorial part and then the more exploration part, but it felt much more structured and much more successful than what we did yesterday. I might have plans for a third surprise live stream tomorrow. So you will see tomorrow if I do announce it. But if I announce it, it will be about reading great articles written by members of the iOS community around WWDC topics. In the meantime, I just want to say thank you for watching. Big thank you to all of the people watching live that made great comments in the chat. I'm looking, there have been 175 messages in the chat. This might be my record in a live stream, but I'm really happy with how it went. And now I think it's time for me to go to bed, because it's more than 10 p.m. in France, and I'm super tired after this big week, but also very glad that I've been able to explore and learn this topic with everyone. This way it feels like it's definitely a win-win situation, and I think I need to stop speaking at some point. So just say one more time, thank you for watching, and see you next time. Bye bye.